Welcome back. So in middle school in Algebra 1, we performed a lot of functions by solving equations. We added opposites, we multiplied by reciprocals, combined like terms, we distributed, maybe we multiplied something to clear fractions. All of that we were able to do by special properties. And we're going to be explaining those properties and then explaining what we're doing using those properties. So behind me are the first set of properties. Addition property of equality, subtraction property of equality, multiplication, division properties of equality, substitution property of equality, and distributive property of equality. So we have all these different examples of how they are in a general sense. So for instance, if we're looking at the addition property of equality, we have A equals B, then A plus C equals B plus C. If you notice, these two things are identical. Very similar to if we were solving a problem like this. Here's our A value. Here's our B value. Our C value would be adding 4 to both of these. Here's my A plus C. Here is the B plus C. Now overall, we usually just work down, and we would then simplify that to make it x equals 14. These 4's would cancel. 10 plus 4 was 14. We can do the same thing for subtraction, multiplication, division, substitution. We know how to distribute. Go through those examples, but very similar to this. So you want to make sure you copy all of these different things here that explain the different properties. Now this is what it kind of looks like when we're putting it in motion. Because now we kind of want to formally explain what we're doing. So if we start with 3x plus 2 equals 23 minus 4x, that's our given. A lot of times in our proofs, we always start with a given, maybe even 2 or 3 givens. So we write the equation out. Now, we want to be able to combine these two terms. We do that by adding opposites. We know we have to add 4x to both sides. That's what we're doing here. This is the addition property of equality. We're adding 4x to both sides. That's where the equality comes into play. Now, after we do this, we can combine these two terms and these two terms and get 7x plus 2 equals 23. So our rationale here is we simplify. Now we want to subtract 2 to both sides. This is the subtraction property of equality. We simplify. 23 minus 2 is 21. 2 minus 2 is nothing. It cancels out. Lastly, we divide both sides by 7. Division property of equality. And when we simplify, we end up with x equals 3. And again, our reason is simplifying. So all of this is what we've been doing in Algebra 1 and pre-algebra. What I'm asking you to do now is giving reasons and rationale of how and why we can do this. Next problem we're going to look at is this one. We have negative 5 parentheses 7w plus 8 and then equals 30. So thinking about those properties we had before, we want to distribute negative 5 to the 7w, then negative 5 to the 8. So our reason is the distributive property. And when we use the distributive property, we end up with this expression now. Kind of explains how we go from here to here. The next step, we're going to add 40 to both sides. And that's the addition property of equality. And yes, you need to write it out. because we have to know that we're adding to both sides, and that's where the equality comes into play. Simplify. We end up with negative 3w equals 70. We can now divide by negative 35. That is the division property of equality. And again, we simplify, and we get our final answer of negative 2. So we're doing our steps, and every step we do, we need to explain how and why we can do it. I'm going to leave this problem up to you. Now, there's other properties there of equality that we can talk about that we will be using probably a lot more in the future. We'll use it some right now, but just to kind of talk about it, the first one is the reflexive property. Very simply, A equals A. Segment AB equals segment AB. We're going to do an angle measure. Angle A equals angle A. Very basic. Symmetric property. Now, we already talked about segments before, but the order a lot of times does not matter. So if A equals B, then B equals A. If segment AB equals segment CD, then segment CD equals segment AB. If angle A equals angle B, then angle B equals angle A. Doesn't matter what comes first. Kind of like if we said, if x equals 5, well, then 5 equals x. Same way, but we're just writing it a different way, depending on how we want it to look. And we can do that because of this symmetric property of equality. The final one, transitive property. So if A equals B and B equals C, then this original A will equal C, and transferring all that information. So if we're looking at segments, segment AB equals CD, and CD equals EF, then this one, AB, will equal EF. Went from here to here, and we can rewrite it like that. Angles work the same way. If angle A equals angle B, and angle B equals angle C, then angle A, which is the first one, will equal angle C. And there's a lot of transitive property problems that we can see throughout the chapter.